Okay, so in the first part there, you saw that we talked about forces being vertical and horizontal, and that was often a good way to solve things. Okay, so horizontal, vertical. But what you're going to see in this one is we're going to change it up slightly. We're going to talk about forces being perpendicular and parallel. Now, if you're interested to know, this still works because these things that we are picking are at right angles to one another, okay, which is the requirement to do this. But let me just show you the situation first. So it says the diagram shows a particle in equilibrium. So equilibrium, that's why we're going to be doing sort of these perpendicular and parallel, and we're going to set them equal to each other. It's on an inclined plane. So an inclined plane, think back to when you're in year 12 or doing year 12 mechanics, when you had like a block on a table, okay? Well, that's what's going on here. It's just that we are turning it, okay? So it's at an angle. And just as you had a normal reaction, you're going to have a normal reaction here. The normal reaction's always perpendicular to the plane. So in this question, that's what the 2 newtons is. Other things you can see in the question, there is quite a lot going on in this question. This one here, this is weight. Weight always acts straight down, whether it's inclined or not. And you can see some other forces being applied here. Okay, so let's get rid of all of that. As I was saying, in the question, anything else? Yep. Can you see that yellow angle that I've said here? So we've been told that the angle made with the ground is 30 degrees. Notice that's the same as the one that I've shaded in there, okay? And you will find that that is always true. So here's what we're going to do. We are going to break up any forces that do not fit into our sort of system that we said over on the left there. Any forces that don't fit in with that system, we are going to break them up. So 2 newtons already fits my system. So I'm just going to make it green so we can see which ones are good. Okay, and I'm going to leave it at that. Now, what else can I do? So this 5 underneath is currently not perpendicular, right? It's not perpendicular and it's not parallel. So that's not good. I need to break it up, and I'm going to break it up by sketching on a right angle triangle. And can you see that the way that it's made, because you'll have to make these yourself as well, is it's made by putting a perpendicular and a parallel part together. So that there would be a correct one. And then I know that the hypotenuse is 5 and that this is 30. So this side here must be 5 cos 30. Just like we were doing on the other one, okay? It's 5 cos 30. So I'm going to draw that arrow there, 5 cos 30. Okay. I could do the other one, but let's just carry on with perpendicular for a moment. Anything else? Well, this is already parallel, so I'm going to leave that one alone. Okay. But what else does seem to work is this one here. So this, which again is a right angle triangle I would need to sketch on sometimes, okay? This is opposite and it's P. So this one here is called P sine alpha. Okay, so that's sort of the first bit done, and I can even start making an equation on that. So what I'm going to do is I'm going to say that all of the forces here plus all of the forces here add up to 0. That's one way you can think of it if you like. Or I'm going to say that the forces acting this way are equal to these forces here. So that is that 2, let's try that again, 2 plus P sine alpha is equal to 5 cos 30. Okay, so that's my first one. Let's go back in now, and now let's handle the parallel ones. So I'm also going to make sure that everything is parallel, like I've done here. So let's use a different color. Let's go with purple. Apologies, I think the whiteboard is struggling to cope with just how many questions are on the board at the moment. So let's go purple. Yep. So this one I'm going to just shade in straight away. That 8 is already parallel. I don't need to do anything with it. Where next? Let's go over here. So where is what's this side here? Well, this is using P. It's adjacent. This is P cos alpha. Notice how the one above was P sine alpha. This is P cos alpha. Any other ones to do? Well, I wonder if you can see it and if you can answer it before I can. What's this one going to be? Notice the way I'm drawing the arrows as well. The arrows chained together to make the original one. Well, that was cos. So this one here is going to be 5 sine 30. Okay. Now, if I just zoom out for a second, we can ignore the forces that we have resolved. We've done those ones there. Can you see that everything's covered? Everything has been either identified as a perpendicular force or a parallel force. And now I'm going to make an equation with them. So what am I going to do? I'm going to say that the two acting down the slope are the same as the one acting up the slope, because I'm told that it's in equilibrium. So the one acting down the slope is the same as the one acting up the slope. So that is 8 plus 5 sine 30 must be equal to P cos alpha. Okay. And again, from there, I should be able to work out these numbers. So if I rearrange the top equation, I can make it P sine alpha equals 5 cos 30 minus 2. And then I can divide this sine by this cos, which would give me what? It would give me that tan alpha must be equal to, let's write the sine part, which is 5 cos 30 minus 2 must be divided by 8. 8 plus 5 sine 30. Okay, so that gives me a way there of finding out my tan alpha. And you should get that alpha is approximately 12.5 degrees. So notice that the yellow ones in the question were the same. Yeah, but alpha was different, okay? So I can get my value for alpha there. And then if you sub alpha back in, you should find that P is equal to 10.8. Okay, I'm not going to go through substituting that. You're more than capable of doing that. The key idea here, though, is that we break things into perpendicular and parallel. Okay, we're going to do just a couple more. So pause the video on this one first and see if you can make the right angled triangles yourself first. So I'm assuming that you've now done that. Let's zoom right in and let's start off. So this will take a bit of practice at the start, but that's your triangle, okay? Your triangle looks like that. It's not any kind of like, I don't know, something like this or whatever, all right? It needs to match what is being done in the question. It needs to match with your normal reaction. Okay, so that's how you draw your triangles, please. So we're going to go like that. Q also needs to be drawn. So how is Q drawn? Q is not. So again, I'm going to say not because I think knowing what it's not is actually quite worthwhile. It is not this. This is completely wrong, okay? It needs to fit in with the rest of the diagram. So it needs to be like, if that's that, then it's going to be like this, okay? So, yeah, and like that. Look at how my arrows follow together to give the same as that journey there. That's another test that you can do. What else? You can put a 30 on there. That will always be the same, remember, that one and that one there. I'm going to put some colours on now. So let's put some colours on, and we are going to do purple. It's going to be parallel for this one. So that's a purple. This one's a bit hard because it's sort of in the way of one another. So what I like to do when it's like this is maybe just draw it slightly above so you can kind of see. Okay, so there's one going down the slope, that's the 5, and then there's some of it going into the slope, sorry, up the slope, if you like, which is from Q. I think that's it. Any other colours? Let's put some colours on. So let's do perpendicular. So that's going down, that's going up, that's going down. Okay, and let's see these ones here. Are they done? Yep, that's been resolved. That's been resolved. 5 was already good. 14 was already good. Let's write down what they are. So this one here is opposite the 30. SOHCAHTOA, sine opposite. So this is 6 sine 30. The 5 is absolutely fine. This one here, if this is beta, this is the adjacent side. So this one here, this is the only problem with these questions. Is a bit hard when they do this one here. This is Q cos beta. So there is 1, 2, 3 for that one there. Let's do the green ones again. So the 14 is absolutely fine the way that it is. This one here, what's this one here? This is Q sine beta. So notice that they often come in pairs. Look, you've got like a cos and a sine for that one, right? How about this one here? Well, that's the sine, this is the cos. Okay, it's the adjacent side. There we are. If you didn't get that, pause now and see if you can finish off the question, because it's more or less the same every time from here. So I'm going to do now that the 14 must be equal to the ones acting into the slope. So that's Q sine beta plus 6 cos 30. Done, done, done. All the green ones are done, so I've got all the forces. Okay, purple now. So I've got going down, going down, going up. So let's do the ones going down first. Yeah, let's do the ones going down first. 5 plus 6 sine 30 equal to the one going up. Well, that's Q cos beta. And there we are. Those are our equations there for us to work it out. What are we going to do? You know, no great surprise here, okay? You get these ones on their own. You solve it from there. You should end up getting that beta is 47.7 and Q is 11.9. Okay? So we're going to have a go. Just last couple. Once you've done enough of these, they are the same every single time. So just, oh no, I think we've actually done them, haven't we? So that's actually our section there complete. Okay, so what was the theme and what's our journey so far? Initially, we've said in equilibrium, up equals down, left equals right. But you can turn that concept and you can talk about perpendicular equals parallel.